In this video, we'll go through a workflow to model the geometry of our stored stripping material adjacent to our road. So we're going to model a windrow to store our material that we're not using in our subgrade. And we'll also account for the movement of said materials. For that, we're going to use the optimizer in both cases, both for material movement and geometry. But the same workflow that we're going through here, all the setup can be adapted to a traditional design where we're manually adjusting the profile. So just to start, we'll look at what we have here in this design. So we've got our stripped surface shown as a dashed line. And if we go to assign by range, we can see that that site prep is assigned here. So we've got 2 meters of overburden removal, and the extents are based off slope stakes based. So it's going down to the extents of our subgrade, and that's that. So let's start by creating a new ground type. That new ground type is going to represent our stripping material. So I'll click new, I'll call it OG, I'll call it organics for description, and I'm going to set my fill to indicate that it's going to double in size after that primary excavation. So we're working in bank cubic meters. We've got our fill factor set at 1, cut factor set at 1, and our fill factor is going to be 0.5. So it's going to double. That makes sense. We've got a lot of organic materials, sticks, stumps, etc. There's going to be a lot of voids in that when we actually store it. In the cost tab, we should update our cost to represent, well, this isn't going to cost as much as a normal excavation. A lot of it can just be grubbed out by sweeping the bucket back and forth, so it will cost a little less. And then the embankment cost, we don't actually have to shape it into a road or compact it. So I'm going to say that my embankment costs are going to be the same as my free haul loading costs. Oops. So we'll hit OK. We'll hit OK. Now I'm going to create a corridor surface. So I'm going to just access that. It can be accessed in a variety of different spots, from the section view to the 3D view to the ribbon. I'm going to do it over here. I'm going to click Add, New Corridor Surface, based off horizontal alignment 1, and I want it to be our strip surface, and I'm going to make it cyan so we can see it. Now in my section view, I'm going to add that in. So I've hit the little plus next to our reference surfaces, and I need to make sure that reference surface that we want to see is displayed, so we'll put the checkbox next to it. Now I'm going to create a new alignment, so I'll right-click in our Project Explorer panel. We can have that accessed by clicking that button if it's not already set. Click Add, Horizontal Alignment, Duplicate from Horizontal Alignment 1. There we are. Now in here, I'm going to go to Assign by Range, and I'm going to remove my overburden removal settings. We're going to account for this as a follow surface instead of assigning the stripping for this alignment. There we are. So we can see that's going down to our topo surface, but that is still showing us the stripped surface associated with horizontal alignment 1. Now let's go into our templates, and we are going to create a new template that shows what we want to account for. So we'll click Add Template. We'll call it STRP. Stripping with windrow. We are going to add in this follow surface component. So paste as new. Now the options in here, we can set the horizontal extents to whatever we like and whatever suits our project. For this I'm going to set it to go out to a maximum distance of 65 meters. Our surface, in this case we only have one surface that we can pull from right now, but we could have many. So this just lets us assign whatever one we'd like. So horizontal alignment 1, strip surface. And we could set that to close to our topo surface. We don't have to in this case since that strip surface is already closed to our topo surface. Now with this, my project is set up where I've accounted for the materials that are suitable to build with in my ground types, but I haven't accounted for what I'm going to strip. And so with that, my ground types, I'll account for it here. So I want that follow surface layer, anything we're excavating there to be associated with surface volume 5. And I'm going to copy that and paste it onto the right. Now we'll also set up our windrow. So that is following the stripped surface. Our windrow has a connection point to be the outside of any surface. So I'm going to take that, I'm going to hit copy. I'll paste it in as right. So that's attached to the outside of our stripping. So regardless of where our center line is, be it left or right, that's still going to have that attachment point. Now what changes though is our windrow height is set to be based off of distance from center line. So we've got that set to be 0. We're not using a reference feature. So if I move our alignment up and down, that stripping goes up and down as well. We'll hit copy, we'll hit paste as right. And there we are. Stripping with windrow. We'll hit OK. And we are going to assign that new template along the length of our road. So from there to there, click Add Edit. Just for the visual here, we're going to set up our 3D view to include that windrow. So I'll click Add, Corridor Surface, based off of a surface from horizontal alignment 2. I want it to show surface volume 6. And we'll set that color to be maroon. Now I should have done this when I was in the templates, but I need to assign the materials that are associated with these since they're being tracked as surfacing layers. So that's being tracked as surface volume 5, that's being tracked as surface volume 6. So my materials, I'm going to say surface volume 5 is organics and surface volume 6 is organics. Neither of these is replaceable, so it's always going to pull in that material and those costs associated with that material. So now let's optimize. So the optimizer is going to move our vertical alignment up or down. We can see that the windrow height is set based off our current vertical alignment. So we'll go in here. I'm telling it that our vertical alignment can be 10 meters either side of our, I'll go with center line, existing vertical center line in this case. I'll go to my standards. Now we don't have to worry about driving on this, so I'm going to go with polyline. So I don't need curves, I can just have abrupt changes in grade. Now my grade can be really steep, it just has to be less than the angle of repose in this case. So we'll set that, and I can have any grade break I'd like. We'll hit Add Edit. Now I won't worry about control points, pits, etc. So control points, there's no location where I need that windrow to be at a certain height. Pits, I expect we're going to be balanced or very close to balanced since we're accounting for that storage of material adjacent to our road rather than hauling it away. if I expected to haul it away or wanted it to haul away, I could add pits to spoil that material at. Unit costs we've already talked about for the material that we're dealing with in this instance. And constraints. So constraints, I'm going to tell it that I only want to allow my material to be moved backwards. So it's fairly steep. I'm not going to pioneer past the heading, so we can only move material backwards. And I'm going to add a full bench constraint to add a couple locations. So here I don't want to have any fill spilling off below my road, even storing stripping material. So from station 570, I have a couple things going on. On one side of the road I have a creek. On the other side of the road I have to worry about fill extending down onto the lower leg of a switchback. So we'll assign that. And then for a short section from station 670 to 690 is just too steep. I don't want to store my material there. We'll hit OK. We'll hit vertical optimization and we'll process that. So there we are. We can see our material movement. We can see the windrow showing our stored material. If we look around here, we can see that, well, that is that 670 to 690, and I'm in full bench, which is good. And then I've got no fill through this section as well, so another full bench section. And there we are. So that also explains why just before those sections where we have that backwards material constraint, movement constraint, we've got more material being stored. So all that material has to be moved backwards to be stored there. So there we are. We've got our stripping geometry. And yeah, right now they're decoupled. So I just have my stripping accounted for in this geometry. But if I were to move that alignment, I could still make the adjustments and it would account for the appropriate stripping volume at that location. So it's still dynamic, but we're just accounted for our stripping in this alignment. Oh, and lastly, aside from just the opti-haul diagram, we could show a mass haul diagram, show similar information. But let's check out the data table here. Oops. So I don't have subgrade material in this. I've got my volumes. I've got surface volume 5 is a cut, and surface volume 6 is fill. So we can see that we're very close to balancing, not quite, but close. 40,000 cubes, 39,000 cubes. So we're moving a lot. We are accounting for that movement. We can see that breakdown in the overhaul, or in the opti-haul diagram. And if we want that detail breakdown, we can copy that to clipboard. And we can see a lot of metrics. Of course, here we've got our actual movement summary from station to station with our volume and distance. And since we're only moving organics in this case, we've got that split out just for that. But if we had have included other materials, we could have that by material type.